We're going to move on to integration, and then as we do exam practice, I will fill in some of the gaps on some of the derivative stuff that we are running out of time on. The only thing that we really haven't had time to look at are what we call optimization problems. I'm just going to cross my fingers that we don't see a whole lot of that on the exam. I don't think we will. But even if we do, optimization problems just simply mean you're looking for the maximum or the minimum of something. So like they'll say, hey, this is your swimming pool, and they'll give you a function that represents the amount of water in the swimming pool. And then they'll ask you, what's the largest size that you could have or something like that. That's a maximum problem. Yes, that's what I'm saying. So I'm not going to officially cover optimization problems because we're out of time. But if you encounter it on your exam, I think we'll be able to work through it. Okay? So as we practice with the exam, hopefully we'll see that. So what I'm going to do is just kind of finish up with the first and second derivative test stuff. And then next week I want to start with integration. Okay. I believe that the derivatives is the most crucial and the most difficult part of this course. Integration is the opposite of derivatives, it's literally the opposite of derivatives. So when you get to Calc 2 or Calc BC, you'll do integration that's much harder than what we'll do in Calc 1. But the level of integration that we do in Calc 1, I don't think is as hard as derivatives. And I think a lot of it is that you have such a foundation and such an understanding of derivatives that by the time we start integration, you're like, oh, I got it. Okay. So we've spent the bulk of the year on derivatives. Okay. So we are still in our Unit 5, Unit 5.3. We've already talked about this. We're just going to kind of clean it up and maybe fill in some gaps. Before I forget, Friday's win, I specifically put in as AP Calc AB exam prep. So if you want to come to Friday's win, we're actually going to go over, start looking at some actual exams and working through whatever problems we can work through. And I'll start teaching you some things that we haven't covered or that we've skipped over. I'll fill that in. Yeah. Absolutely. Yes.
You specifically said AB, and I'm like,
yeah, you could, because most of BC, really, to be honest, if you could probably get a 3 on the BC exam without learning anything new. So most of the BC exam is AB stuff. Okay.
you should take both then.
No.
Some people do.
Because then if you go to AB and you get like a 4 or 5 on the AB, then you might get like a 3 on the BC.
Yeah, you can't now. You have to. Some schools actually do not treat BC as Calc 2. Some schools treat it as you can either take AB or BC.
They also get the AB subscores, right?
Yes, you can get the AB subscores in your BC. Yeah. We don't do that because we're hard pressed just to get through the material we need to get through for AB. So trying to get through the additional material for BC, having not had the AB foundation, would be impossible.
Is BC different from college Calc 2?
No.
Okay.
And in my opinion, Calc 2 is the hardest of all the calculus classes.
Oh.
I don't know why. I just know that's the one I had the most trouble in. Everybody I've ever spoken to, Calc 2 is the one they had the most trouble in.
Oh, yeah, because there's hyperbolas and all that kind of stuff.
Yeah, but I went all the way up. I did Calc 1, 2, 3, 4, and Advanced Calc 1, and Advanced Calc 2. So it's the equivalent of Calc 6.
Yeah.
2 was the hardest one. So
Yeah, one of my friends.
Series and stuff. I haven't gotten there.
so much stuff. It's just so
I haven't gotten there yet. I'm a little worried.
yeah.
So,
Yeah.
sorry, when we go to college,
I'm scared because I'm scared what's going to look like.
Yeah. I believe that Calc 2 is the hardest one. That's why you guys should take Calc 2 in college, regardless of your score. You
So
know,
one of my friends is taking Calc 2 right now.
yeah,
And I was like on a call with him.
it's beating them up, isn't
And he
it?
was like, he was doing it with me, and I was like, what's one of the problems? And like, not one of the words I understood was integral because you said it like once.
Yeah. Yeah.
Okay.
Alright.
Yeah.
So when we go to college next year, not BC, AB, should I take Calc 1 again or should I go to Calc 2?
If you get a 5 on the exam, go to Calc 2. If you don't get a 5 on the exam, take Calc 1.
So I'll be going to college. Alright.
Okay.
That will make it easier. You know what, maybe I don't like
And
college.
you'll find you're gonna like. Hey guys, this is a really good question. Should you take Calc 1 next year? If you get a 5 on the exam, no. If you don't get a 5 on the exam, take it again, because you're going to get a really good foundation, and it's going to be a grade that you'll get a good grade in. You're going to start nice and strong, you know. And a lot of the colleges, like if you're majoring in math, most of the colleges are going to make you take the Calc 1 at their school, regardless of what your score was. But a lot of the colleges like you to take it with them because they're going to teach it their way. And they all know that in high school, it's hard to get through the material we need for the exam. So they know we skip some things. You know, it's just a fact. We have to make choices. We're like, okay, I'm going to skip optimization so that I can get to integrals. Well, they don't want you coming in not knowing that. So they would prefer that you took it again. But if it's the only math class you're going to have to take and they accept your AP score, then fine, just let it go. You know, if this is the only math class you're going to have to take in college, take the credits for it and move on. But if you're going to have to take more, if you're going to have to take Calc 2, and a lot of you are, then retake Calc 1 first, unless you get a 5 on the exam. But for a lot of you, this is going to count as your college math class. Like those of you that are going into music, you're not going to have to take another math class if you have Calc 1 as a credit. So if they accept it as that only math class you have to take, go with it. You know, it's not like you're going to need calculus in your music major or your communications major or your sociology major, right? You're not going to need it. But if you're going to have to take Calc 2, take a Calc 1 again unless you get a 5, because that's going to give you a really strong foundation, because I'm telling you, Calc 2 is hard.
What if you get a 5 but you don't feel like you know it still? Because like I got a 5 on a couple of exams last year, and I'm kind of like, how did I get a 5 on that?
I will tell you, you will not get a 5 if you don't know it.
Okay. All right.
You will not get a 5.
Because you can't guess.
No, you can't. You can't. I mean, you do. You
That's
have to know
true.
it.
I guess it's not like an English AP.
Right. You're not, if you just get them, if you ace the multiple choice,
Yeah.
if you ace the multiple choice, you're going to pass the exam, but you're not going to get a 5. In order to get a 5, you've got to do very well on the free response questions. And if you don't know it, you don't even know what they're asking in the free response questions.
How many things do you have to get right?
Oh, God.
It's like
70-something%.
it's like 65 to 70, I think.
Okay.
Yeah.
That's crazy.
But
It's not that bad.
But it's,
Well, if you think about how that's how you get the top score, that's 65%.
So that's
Think about how hard
That's a good margin. It's like a good like.
Well, that sounds good because you're like, oh, it's easy to get 65% right, but if the top scores you only get like a little
yeah.
Well, I already know what that was like after 10. I sat down, I knew the first problem, I'm like, yes, I know how to do that. Flip the page.
They do get progressively harder. Yeah. Okay. All right. Here we go, guys. So our first derivative test. Okay. Let's get focused now, right? We know that we can find the absolute maximum or the absolute minimum just by doing a candidate's test, right? And that's where you find your critical points and then you just plug them in and compare the results, right? That's what we just finished doing. We can also find the minimum and maximum by using the first derivative test. And we talked about this before. So the first derivative test, okay, if we look at an example like this curve here, we take the derivative, right? And we set it equal to 0. And by doing that, that's going to tell us at what points the slope of the tangent lines are 0, right? Okay, I don't want to go there, right? So when we take the derivative and set it equal to 0, we're finding those critical points, those points where the tangent line could be 0. We're also looking for the points where the derivative is undefined. So that would be like here, right? And what's going to happen when we look at this, right? If we have a maximum, whether it's relative or absolute, right? We're going to have an f of x that's going to go from increasing to decreasing. And what the first derivative test tells us is that the derivative is 0, which means this tangent line is 0, which means we have a potential change from increasing to decreasing, which means we have a potential maximum or minimum. That's what the first derivative test does for us. We're going to jump down and we're going to look at a couple examples again. Oh, let me just go through these to make sure I'm not forgetting to tell you anything. Let's see here. At a maximum value, f changes from increasing to decreasing. Okay. F prime changes from positive to negative. Okay. So here was the example we just looked at, right? F went from increasing to decreasing. F prime, right? F prime is the slope of the tangent line. So if you look at the slope of our tangent lines here, these tangent lines all have a slope of positive numbers. Once I get here, my slope of my tangent line is 0. And then after I go past there, look at all these tangent lines. They have a slope that is negative, okay? We did not spend very much time with studying the graphs going between f prime, and f double prime, okay? We will look at more of that when we actually do practice problems. That's something that's somewhat intuitive, but we'll kind of be pulling it together as we do practice exercises. So please, we're going to spend a lot of time doing practice problems and doing old exams. I'm teaching you during this process. This is not like one of the problems with that. One of the reasons sometimes I hesitate to do that is because some students dismiss class like, oh, we're just doing practice exams. No, I'm going to be teaching you through that process. I want to give you the practice exams, but we also still have things to learn from it, okay? And that's one of the things. We're going to look at the graphs and how the three connect together, okay? Okay. A minimum value. Minimum is F is going to go from decreasing to increasing. F prime will go from negative to positive, okay? Okay, at each relative local extreme value, F prime, okay, let's look at this graph. At each relative local extreme value, F prime is either 0 or undefined. Okay, at each relative local extreme value, F prime is either 0 or undefined. Okay. Let's see here. We're going to skip all this. Okay. And we're going to skip all of that. And we're going to skip down. Okay. This is page 13. Because we've talked about this stuff before, so I don't want to spend too much time going over it again. when we're trying to find the intervals where f is increasing or decreasing, right? First off, again, we're talking about f being continuous on that closed intervals, right? We have to find the critical points. Critical points include what numbers? Vertical asymptotes, okay. And what else?
X values, like the zeros.
The zeros of the derivative, right? Okay. And discontinuities, right? So those are all critical points. Then we're going to create a number line chart. Okay, let's look at an example and pull this together. Let's look at example 3 here, okay? Find the open intervals on which this function is increasing or decreasing, and then justify it, okay? So usually these are in a non-calculator section because we can easily plug that into our calculator and see where it's increasing and decreasing. Usually this is a non-calculator section. So the first thing we're going to do, in order to know where it's increasing or decreasing, look back at this curve, right? I have to look at the derivatives. I have to look at the slope of the tangent lines, okay? So we're going to take the derivative. So f prime of x. Okay, go ahead and take the derivative. I'm going to let you do that. Okay, so we should have 2x squared minus 2x minus 4. Okay, everybody good with that? What do we do now? Set it equal to 0, because I'm looking to see where those tangent lines are horizontal. So I'm going to take a 2 out, and that gives me x squared minus x minus 2. Okay. There's one thing I failed to do. Does anyone see it? We're going to simply state f of x is continuous. Right. And it's differentiable. But that's kind of obvious since I took the derivative. I don't really have to state that. Okay. Okay. This is where most of you are going to struggle. Finding the zeros. It's the algebra, right? So we need to find the zeros. So 2 does not equal 0. So I'm looking at x squared minus x minus 2 equals 0. So I'm going to factor, and some of you really struggle with the factoring, and that's going to just come back and haunt you. Just giving you that little word of encouragement. All right, so we get x equals 2 or negative 1. We don't have any points of discontinuity, so I don't have any other critical points, right? This is on an open interval, so there's no endpoints to consider.
Excuse me, Ms. Murray?
Yes.
Hi there, can I have Camp Pantano report to the gate over by Ms. Kathy's office?
Okay.
Thank you.
Okay, now, the next thing we're going to do, right? We're going to create a number line chart using these critical points. We're going to create a number line chart using these critical points. So these are the possible places. The critical points are the possible places that it might be changing. It doesn't mean it is, because it could be going like this, right? That's increasing the entire time. But these are the possible places that it might be changing. So we put them in order, lowest to highest, right? X equals negative 1, and then 2. Okay. Okay. So let's look at some values here. So I'm going to see, I'm going to say let x equal negative 2. And here I'm going to say let x equal 0. and let x equal 3. These are the values I'm going to examine. Okay. So we're going to look at f prime. What is f prime doing when x is these numbers? Okay. So I like to look at it in the factored form. It's just easier, right? So if it's -2, I'm going to get a negative times a negative, which is positive. When x equals 0, I'm going to get a negative times a positive, which is negative. I find it easier to put it in the factored version than in the original version. Okay, there's less calculation because I don't really need to know the actual numbers. I just need to know whether it's positive or negative. Okay, when x equals 3, if I put 3 in here, 3 minus 2 is a positive number. 3 plus 1 is a positive number. Multiplying them together, I get a positive number. Does everybody understand how I did the table? Okay, so this means that f, right, that's f prime. That means f of x is increasing, and then it's decreasing, and then it's increasing. Okay? So we were just asked to find the open intervals that are decreasing or increasing. All right, so we're going to say f of x is increasing. Okay, what's the interval that it's increasing on? Mm-hmm.
Negative infinity to -1.
Good. And 2 to infinity. Okay? Now, this is very important because it's very frustrating. If you did this, you have not gotten credit for it. No, we did everything correct. But a table is not justification. They do not accept that as justification. It's so frustrating. I hear you. It's frustrating. We actually have to say because, right, f of x is increasing on those intervals because f prime of x is greater than 0. We have to make the connection between the increasing and f prime of x being greater than 0. This is why we practice the exams, because we want to get the points. We know how to do this problem. And it frustrates me. We know how to do it. You got the right answers, but you didn't get the points because you didn't say what they wanted you to say. Okay? So it's increasing because f prime of x is greater than 0, or you could say f prime of x is positive. Okay? So then we're going to say f of x is decreasing in the interval from -1 to 2 because f prime of x is less than 0. Okay? Okay. Everybody understand how to show the increasing and decreasing intervals? All right, we're going to take it a step further now. Are we good? Take it a step further. Okay. If f prime, this is the actual first derivative test. If f prime changes from negative to positive, then f has a relative minimum at that point. Okay, so what this is saying, if f prime changes from negative, well, when f prime is negative, what do we know about f? It's decreasing. So if f prime changes from decreasing to increasing, negative to positive, then we know we have a relative minimum. Well, that's pretty clear. right? If f prime changes from positive to negative, then we have a relative maximum. So f prime being positive means I'm increasing. F prime being negative means I'm decreasing. So I clearly have a relative maximum. When we justify our work, this is the phrasing we're going to use. Right? When we justify increasing or decreasing, we include that f prime is either greater than 0 or less than 0, right? Positive or negative. Okay. Okay. If it doesn't change signs, then we don't have any relative minimums or relative maximums. All right. We'll talk about concavity in a little bit. Okay, let's look at this example, number 4. Find the open intervals on which f prime is increasing or decreasing and justify. Right? Make sure that when you're answering these questions that you're clearly showing which part you're answering, right? So we're going to do f prime of x equals 4x to the third minus 16x. Okay. Okay, what now? Set it equal to 0. So in order to set this equal to 0, I'm going to give you just a few seconds to do that, and then we'll jump in again together.
It means we don't have to find the domain because they're polynomials.
Correct.
Should we state that it's continuous?
Yes.
Do we have to worry about differentiability?
No. Okay. Okay, so Faith, that was a good question. Do we have to worry about differentiability? The reason we're not going to worry about stating it is that we can clearly take the derivative. Okay. Okay, so finding the zeros. This is where I feared most of you are going to have the most trouble, right? So what are we going to do? Take out 4x. Good. And that leaves us with x squared minus 4. So my critical points are what?
-4
No.
and 4.
0,
-2 and 2.
-2, and +2. Yes. -2 and +2. Okay.
I'm sorry, are you're videoing, right?
Yes. Make sure I'm still video. Yes, I am. Okay. So let's make our table. Let's see. I'm going to do lowest numbers to highest. -2, 0, 2. Okay. So let x equal. Let me see. We'll do -3, 1, and 1. I'm sorry. -1 and 1. Okay. Thank you. Yes. Okay. So f prime. Okay. If I use -3, I'm going to get a negative, right? -12. And then the -3 is squared. I get 9. So I get a positive. So this equals a negative. When x is -1, I'm going to get a negative times a negative, which is positive. When x is +1, we get a positive and a negative. Is that right?
Yes.
which is negative. Okay. When x is 3, I get a positive times a positive, which gives me a positive. Okay. So f of x, right, is decreasing, increasing, decreasing, increasing. Okay. Sometimes, just so that you know this and you don't get confused, sometimes when you see these tables, instead of writing it the way that we have, they'll do this. They'll be like, okay, we're negative over here, we're positive in between, we're negative in between, and we're positive here. Sometimes you'll see it like that instead of writing it out like this. But I liked writing it out like this instead. Okay, so let's see here. F of x is increasing. Let's say negative 2 to 0, right? And, oh, be careful. I see what you're doing. Make sure these are the critical points here. No, this is just, we were picking a point on those intervals and testing it. Okay. Okay, and why is it increasing there? Because, right, make sure f prime of x is greater than 0 there. Okay. And then we're going to do, let's see, f of x is decreasing. Let's see, from negative infinity to negative 2. See, I'm taking my time, right? I've done all the work. I don't want to make any silly mistakes. And 0 to 2, because f prime of x is less than 0. Okay? We have sufficiently answered part A. Now let's answer part B. Determine the x values of any local extremas. We've done all the work. Okay, a local extrema. So if I have a function, my first derivative test says, if f prime goes from negative to positive, I have a relative minimum. Right? Did f prime go from negative to positive? Yeah, right here. And then right here. So we're going to say f of x, determine the x values, right? So f of x has a relative minimum at x equals negative 2 and x equals positive 2, right? And the reason is that f prime of x, we've got to use the right terminology. F prime of x changes from negative to positive. And we'll say here, okay? F of x has a relative minimum, bless you. It's not asking for what the relative minimum is, it just wants to know where it occurs. So f of x has a relative minimum at negative 2 and at 2 because f prime of x changes from negative to positive at those points. Okay, that's where drawing these arrows like this is helpful because you really can visualize it. In order to go from that arrow to that arrow, I have to have that minimum, right? Okay, and then we have to add the relative maximum in there, right? F of x has a relative maximum at, so now we're looking for increasing, changing from increasing to decreasing. So it's at x equals 0. And we're just going to say f prime of x changes from positive to negative here, okay? Notice I didn't say it's going from increasing to decreasing there. I used the wording that the first derivative test is given. I'm not 100% certain that they would mark you off for that. But just to avoid that possibility, let's use this terminology, okay? I said positive to negative instead of saying increasing to decreasing, okay? Although it really means the same thing. Okay, questions? You feel comfortable with this? We've hit this a little bit already, right? Okay. Let's look at, actually, I'd like you to do number 6. You can work in pairs if you want to. Okay, see if you can do number 6 by yourself. Okay. Let's see what we can do here. Go. Okay, so I took the derivative and I set it equal to 0. So now I have cosine x equals 1/2, all right? So I've got to go back up and I've got to think through my unit circle. Okay, where is the cosine positive? That's going to be over in this half, okay? And where's it equal to 1/2? Right here and right here. Now, I know that radians is always a struggle. If you have to figure it out in degrees and then convert it to radians, do that. But we have to show our work in radians because it's stated in radians, okay? So this is 60 degrees. 60 degrees is pi over 3, okay? I'm going to show you again how I remember the radians without converting. I draw myself a little picture, okay? When we're talking about the 30 and 60 degree radians instead of the 45, ignore the 45 for now, right? This starts out at pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Okay, so this was 2 pi over 6. 2 pi over 6 reduces to pi over 3. Okay, so you can reason through it. Okay, this one right here, here's 6 pi over 6, 7, 8, 9, 10 pi over 6. What's happened here? 10 pi over 6, which reduces to 5 pi over 3. Okay. So I have my critical points. Get rid of these extra things here. Okay, I've got my critical points. Now I need to make my table, right? I do have a closed interval this time, so I have to include that in my table. So I'm looking at 0, and then we'll do pi over 3, 5 pi over 3, and 2 pi. Okay, so this time I have to include those endpoints. Okay, now this is an endpoint, so I don't have to go outside of those points. Okay, All right, so f prime of x. So something between 0 and pi over 3. So this is where looking at your unit circle is helpful. I'm going to choose pi over 4. Or you could choose pi over 6. Doesn't matter, right? So looking at f prime, is the cosine going to be positive or negative? It's going to be positive, right? Okay, so we're going to do, this is going to be 1/2 minus the cosine of pi over 4, which is the square root of 2 over 2. Is that going to be a positive or a negative number? Negative, because it's 1 minus the square root of 2 over 2. Well, 1 minus the square root of 2 is negative. Square root of 2 is bigger than 1. So this is going to be a negative value, which means it's going down. Okay. Oh, I make this mistake often. It's not F, it's G.
Do we have to label those for AP exam?
Yes. Do you make that same mistake a lot?
I don't tend to label it if I know it.
Well, because remember, you have to constantly remind yourself, the people that are grading it don't know that you know that. Right? So you have to make sure that you are showing them what you know. They're not allowed to assume anything. Right? When you make a table like this, they're going to look at that table just like I would, and they're going to say, "Oh, okay, she knows what she's doing." They're not allowed to assume that you know that this 1/2 minus the square root of 2 over 2 refers to g prime of x. Although it looks pretty obvious, right? But they can't assume it. They're not allowed to. Okay, a number between pi over 3 and 5 pi over 3. Well, pi falls in that range, so let's use pi. Okay. So that's going to give me 1/2 minus, actually, you know what? Let's use pi over 2. That'll actually be easier. Because the I guess it doesn't really matter, does it? It doesn't matter. What's the cosine of pi over 2?
Like 0.
0. So we get a positive number. So my g of x is going up. Okay. Okay, a number between 5 pi over 3 and 2 pi. All right, we can pick something right there, which is what, 11 pi over 6? All right. What's the cosine of 11 pi over 6? Square root of 3 over 2. Is that going to be a positive or a negative number? Negative. So this may be a non-calculator section. We have to be able to come up with that on our own, right? They both have the same denominator. So I'm just looking at the 1 minus the square root of 3. Square root of 3 is bigger than 1, because square root of 3 is bigger than the square root of 1. So that means it's going to be a negative number. So it's going down. Okay. Find the exact values of any relative extrema. Okay, so let's see here. G of x has a relative minimum of, so where is that occurring? At pi over 3, right? So g of x, so g of pi over 3 equals 1/2 pi over 3 minus the sine of pi over 3. That gives me pi over 6 minus, what's the sine of pi over 3? No, actually it's the square root of 3 over 2. Okay. And we can leave our answer just like that if it's a non-calculator section. G of x has a relative minimum of pi over 6 minus the square root of 3 over 2. Right? We're going to give comma. Since g prime of x changes from negative to positive at x equals pi over 3. Okay. Okay, see if you can state the relative, yes, question.
How come we have to plug in pi over 3 into that one? Like the other example we look at it.
So in order to find where it's increasing and decreasing, we plug it into the derivative because we're looking at the slope of the tangent lines, right? But if I want to know the actual maximum or minimum, okay, go back up to this picture again. Okay. So by looking at the slopes, I can tell, hey, this is going to be, right, I'm going from positive slopes to negative slopes. So this is my point where the slope is going to be 0. So that's my relative maximum there. To find the actual relative maximum, I need to know the y value at this x point. Does that make sense? Okay. So that's a good question. We use the derivative to determine where it's occurring, but to find the actual relative extrema, I have to plug it back into the original function. Okay? Okay. G of x has a relative max of, okay, well, where's the relative maximum occurring? 5 pi over 3, right? So I need some space here. Let me see. I'll go down here. G of 5 pi over 3 equals 1/2 minus, 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. And that gives me 5 pi over 6 minus, now here's my 5 pi over 3 right here. And the sine, remember, is the y value, so that's negative square root of 3 over 2. So this is going to be a relative maximum of 5 pi over 6 plus the square root of 3 over 2. Since g prime of x changes from positive to negative, make sure you state where that happens, at x equals 5 pi over 3. Okay. Everybody understand that? Okay, how much time do we have left?
Like 19 minutes.
Yes. Keep going. All right. I'm going to go ahead and I'm going to skip because this is just more of the same practice, right? You've did this before. I just want to make sure we get our terminology right. And we talked about this before, right? Make sure you answer the question. Are you looking for the extreme values, which would be the y values, or where the extreme values occur, which is the x values? So I know we've talked about that before. Okay, any questions on the first derivative test? Why we do what we do or why we phrase it the way we phrase it? Okay, I said we're going to move on, but I want to do this one example for you. Let's look at example 9 together. We won't work through the entire thing, but this one is a little bit different. Okay, let's take the derivative, right? G prime of x equals low d high, so 2x, minus high d low over low low. So we're looking at 2x squared minus 4x minus x squared plus 3. So we have x squared minus 4x plus 3 over x minus 2 squared. Okay. So we're looking for a critical point. So let's set that equal to 0. So I'm going to factor that numerator because I can see that it will factor. Okay. So x equals 3 and 1. Right? That's where it's going to equal 0. But we also have to include the critical point of what? 2, because G prime is undefined there. Okay. So I have to also include the 2. So now when I make my table, I'm going to do 1, 2, and 3. Yes.
Wait, isn't 2 not part of the domain though? Because if 2 is part of the domain, it'd be undefined.
But undefined points will be critical points.
I was thinking of the original g of x, part of the domain.
Let me see what happens here. X squared minus 3 over x minus 2. X squared minus 3 over x minus 2. Okay. So if we look at this one, okay.
What is that like even graphic? Like,
This line right here in the middle is actually not part of the graph. That's an asymptote.
oh,
I'm not sure why it's showing up actually.
This is the exact asymptote.
Oh yeah, there it is. There you go. Okay, so if we look at this, right, we've got a change in sign here, right? So we have to examine this critical point just to find out whether or not we have an actual change in sign for the derivative. If the slope of the tangent changes direction there, we have to actually consider that point, even though it's undefined there, and that's not part of the domain. I'm trying to remember. Let me just go back up a minute, all the way back up. Where were we? Critical point. Okay, so this is right. So because it's not part of the domain, actually, I'm glad you said that because it's important that we indicate that. Since it's not part of the domain, we're not going to call it a critical point. However, when we're doing our table, we have to include the points where it does not exist. So if you remember back up here, let's see here. Where did we see it? Okay. Here we go here. So when we're looking at the intervals, right, we have to find our critical values and those points of discontinuity. Okay, which means when the function does not exist at that point, that's a point of discontinuity. So we're going to include those in our intervals. If we were asked for the critical points, it would just be 3 and 1. Okay. Okay. So when we do this, we're going to find that g prime of x will be positive here. I'm just saving us some time. It'll be negative here. It'll be negative between 2 and 3, and it'll be positive here. Okay, so g of x is going to do this. Okay, so here we find that we do have a point that we're examining where we don't have a change in sign. Okay, so when we're looking for those intervals of discontinuity, intervals of increasing, it's going to be from negative infinity to 1, and also from 3 to positive infinity, right? And the reason here is that g prime of x is greater than 0. I'm just abbreviating to be quick. And then it's decreasing from 1. Okay. Do we just do 1 to 3? Why not? 2's not part of the domain, so we can't do 1 to 3. We have to do 1 to 2 and then 2 to 3 because g prime of x is less than 0 here. Okay? And then it says find the x coordinates where it has relative maximum or relative extrema. So it has a relative, and we can see by our arrows, right? A relative max at x equals 1. Okay, and we're going to state it, even though we feel like we stated it up here, because it has to be stated differently. We're not going to say g prime is greater than 0. We're going to say g prime changes from positive to negative. Okay. It has a relative min at x equals 3. And the same thing again. G prime of x changes from negative to positive. Okay. Okay, I think tomorrow I will do the second derivative test. What I'd like you to do, there is 12 to 18. Where is that? Oh, that's the homework. So in your Google Classroom,
I remember some